Elementary reaction andre eno, it will complete in the single step. Single step alli reaction complete agutte. The rate of formation of C, rate of formation of C andre, this is the rate of formation. Now is 9.6 into 10 to the power minus 2 mole per liter. What will be the rate of reaction? Delta H kottidru. How much they have given? 60. Plus activation energy of the forward reaction also they have given 150, minus they are asking activation energy of the backward reaction. Hello my dear friends, ಹೇಗಿದ್ದೀರಾ? ಎಲ್ಲರೂ ಚೆನ್ನಾಗಿದ್ದೀರಾ? ನಾನು ಇವತ್ತು ನಿಮ್ಮ ಮುಂದೆ ಬಂದಿದ್ದೀನಿ with KCET Super 30 questions. ಕೆಮಿಕಲ್ ಕೈನೆಟಿಕ್ಸ್ ಇರೋ ಅಲ್ಲಿ ಎಲ್ಲ ಕಾನ್ಸೆಪ್ಟ್ ಇಂದನು ಕ್ವೆಶ್ಚನ್ಸ್ ತಂದಿದ್ದೀನಿ. Now in this, with these questions we can see in what way, in what different type of the questions they are asking in the KCET. Okay, now let's start our questions. Now first question nodi. Now what they are asking, the rate of reaction is expressed in different ways as follows. Now rate of the reaction kottidira avaru. Now the reaction is with this option, with these options A, B, C. Now which one will match this rate of the reaction? Now rate of the reaction andre eno, munche rate of the reaction is equal to change in concentration by change in time, right, by its stoichiometric coefficient. Now change in concentration by change in time by stoichiometric coefficient. Now write the rate of reaction for this one. How we can write? Now here the stoichiometric coefficient for this one, it is A. 4A plus B gives rise to 2C plus 3D. Now 1 by 4, its stoichiometric coefficient 1 by 4 minus D concentration of A by dt. Illi nodi, why I am keeping here minus? Because concentration change in concentration alla C final minus C initial, C final minus C initial. Illi nodi, now C final minus C initial alli, now munche if starting, if you have taken 100 molar of the concentration, now reaction start agida mele enagutte, reaction molar concentration kadime agutalla, means final concentration will be less than the initial concentration. That's the reason the change in concentration, it will get the negative. If the change in concentration negative, if it is negative, now the rate of the reaction will also be a negative. Rate of the reaction should not be the negative. For that reason, for the reactants, we will keep it as a negative. Now for the products, rate of the reaction for the products, we'll give it as a positive, and it is stoichiometric coefficient. Now let's see, is equal to, now here there is no any stoichiometric coefficient. Here the stoichiometric coefficient is 1, so we can write change in concentration by dt is equal to, now here the stoichiometric coefficient is 2 plus D concentration of C by dt. Now I am erasing this one. Now is equal to, now 1 by 3 plus D concentration of D by dt. Now is this rate of reaction is matching with this one? Now let's see. Now here concentration of A, here it is positive, but here it is in the reactant side, it is negative. So this option is wrong. Now let's see for this one. Now here minus D concentration of B by dt is equal to, now here 1 by 3 minus D concentration of D by dt is equal to, next 1 by 4 plus concentration of A by dt is equal to plus 1 by 2 concentration of C by dt. Now see this one. Now this rate expression, is it matching with this one or not? Now minus dB by dt, minus dB by dt. Now here also d minus dB by dt. Next 1 by 3 minus dd, d concentration of d by dt. Here also minus 1 by 3 d concentration of d by dt. Now ಇಲ್ಲಿ ನೋಡಿ. Next 1 by 4 change in concentration by dt. Now here also 1 by 4 change in concentration of dt. Now here plus 1 by 2 change in concentration of C by dt. Now here also plus 1 by 2 change in concentration of dt. But this rate expression they have given in the different way. Now by this, with this rate expression, now this option it is matching. Now this is the correct answer. Now this is our correct answer. Okay. Next. Now, next question ನೋಡಿ. Next question ಏನು ಕೇಳ್ತಾ ಇದ್ದಾರೆ? In the reaction A plus 2B gives rise to 6C plus 2D if the initial rate minus initial change in concentration of A at a time t is equal to 0 is, no, its initial rate. Now if the initial rate at the time t is equal to 0 is this much, how much? 2.6 into 10 to the power minus 2 molar second inverse. Now what will be the value of change in concentration of B by dt is equal at the same time t is equal to 0, they are asking. Now first write the rate of the reaction. Now how to write the rate of the reaction for this one? Minus change in concentration of A by dt is equal to, now it's stoichiometric coefficient, right? 1 by 2 minus d by dt now is equal to 1 by 6 plus change in concentration of C by dt now is equal to 1 by 2 plus change in concentration of d by dt. Now ಇಲ್ಲಿ ನೋಡಿ. Now here initial rate of minus dA by dt at time t is equal to 0, how much they have given? For this one, how much they have given? 2.6 into 10 to the power minus 2 molar second inverse. But he is asking, what he is asking? He is asking change, he is asking at the time t is equal to 0. Now what is the value of change in concentration of the B? Change in concentration of the B. Now this we can write 1 by 2 minus dB by dt. Now if you take the stoichiometric coefficient 2 to the which side? Left hand side. ಎಷ್ಟು ಬರುತ್ತೆ ಆನ್ಸರ್? minus d concentration of dB by dt is equal to, now ಎಷ್ಟು? Now 6 to the 12, 5.2 into 10 to the power minus 2 molar second inverse. Which is the answer? Option number C. Option number C is the correct. Option number C is the correct, right? Now next question ನೋಡಿ. Next question ಏನು ಕೇಳ್ತಾ ಇದ್ರೆ? Which of the following statement is incorrect for the zero order reaction? Which of the following is incorrect for the zero order reaction? First, zero order reaction formula ಏನು? Zero order reaction ಗೆ formula ಏನು? Change in concentration Ct is equal to Kt. Now C0 ಅಂದ್ರೆ ಏನು? This is initial concentration at time t is equal to 0. Now Ct ಅಂದ್ರೆ ಏನು? Now this is final concentration yet time t is equal to t. Now k andre enu rate constant. No, t andre time. Okay, now illi nodi, here r naught they have given, here I have taken the c naught. Okay, don't get confused. Now this is initial concentration. No, idu final concentration. Now illi nodi, now first option we should match with this one. Now, can I bring the t to the left hand side? Now t, if I bring the t to the left hand side, now expression ಏನಾಗುತ್ತೆ, k is equal to c naught minus concentration of ct by t, right? Now ಇಲ್ಲಿ ನೋಡಿ, now is this expression and this expression it is matching, right? Now means this is correct. Now next nodi, t of, actually this is equal to, no, t of, now what is the formula for the, now half-life formula for the zero order reaction? T of is equal to initial concentration by 2k. Now this is the half-life formula for the zero order reaction. Now this option is also correct, this option is also correct. Now is the D is correct? All are incorrect. So this is also wrong. Now the answer, it is T 1 by 3 is equal to 2 into 1 half. Actually, so this is the incorrect. This is the incorrect. Next question nodi. Ee question solve madoke munche first we have to know first order reaction formula. First order reaction formula ಏನು? K is equal to 2.303 by T log A by A minus X. Here A andre initial concentration. Now this is final concentration at time t. Okay, next we have to know half-life t 50% of first order reaction is equal to 0.693 by k. Now ಇಲ್ಲಿ ನೋಡಿ, ಈಗ 99% of a first order reaction was completed in 32 minutes. Now when 99.9% of the reaction will complete, for that one I am giving one brief derivation. With this derivation we can find out our answers easily. ಈಗ ನೋಡಿ, now ಈಗ 99% is saying, right? So first K 2.303 by T 99%. T 99% of log percentage, right? Percentage, the initial concentration will be 100. Now change in, now final concentration will be, now 100 minus 99. Now the leftover will be 100 minus 99. Now the leftover will be 1, right? Now T 99% I am taking to the left hand side. Now K I am bringing to the right hand side. Now T 99% is equal to 2.303 by K log 10 to the power 2, can I write? Now this one I am bringing to the here 2 into 2.303 by K log 10 is equal to 1, we know. No, this one can I write 4.606 by K, 4.606 by K. Now this we can write it in this form, 20 by 3 into T of 20 by 3 into T of, we can write in this manner. Now ಇಲ್ಲಿ ನೋಡಿ, Now T99 percentage is equal to 20 by 3 T of, right? Now 20 by 3 T of. ಇಲ್ಲಿಗೆ ನೋಡಿ ನಾವು T99% ಎಷ್ಟು ಕೊಟ್ಟಿದ್ರು 32 minutes is equal to 20 by 3 T of. Now if you take 3 to the left hand side, then how much it will become? 96 by 20 is equal to T of. Now 20 by 96 by 20. How much it will become? How much it will become? 4 ja. Now the leftover will be 16.16. 166 means 80. 4.8. Now T99% T of is 4.8. Now T99% is equal to same. If you solve, if you do the same derivation for the T99%, we'll get 10 into T of. Now T of already we got here. How much? 4.8. 10 into 4.8 if you take, then how much it will become? 48 minutes. T99%. When 99.9% of the reaction will complete. ಯಾವಾಗ ಕಂಪ್ಲೀಟ್ ಆಗುತ್ತೆ? At 48 minutes. At 48 minutes. 48 minute ಅಲ್ಲಿ ಈ ರಿಯಾಕ್ಷನ್ ಕಂಪ್ಲೀಟ್ ಆಗುತ್ತೆ. ಈ ತರಾನೇ ಈ ಡೆರಿವೇಶನ್ ಮಾಡಬಹುದು. For T99 is equal to 10 into T of. Okay. Next question. Next question. Now correct graph for first order reaction is. Correct graph for first order reaction. ಇಲ್ಲಿ ನೋಡಿ ಫಸ್ಟ್ ಏನು ಕೊಟ್ಟಿದ್ರು? T of versus initial concentration. T of formula ಏನು? T of for the first order reaction is equal to 0.693 by K. Means T of is not dependent on initial concentration. Now, T of initial concentration ಮೇಲೆ ಡಿಪೆಂಡ್ ಆಗ್ತಾ ಇಲ್ಲ. ಓಕೆ. ನಾವು ಇಲ್ಲಿ ನೋಡಿ T of versus R. Now when the T of is not depending on the initial concentration, now here the graph they have given straight line. Is it correct? When it is not depending upon the initial concentration, now here straight line ಬರುತ್ತೆ. ಯಾಕಂದ್ರೆ T of is not depending upon the initial concentration, but here you have given the straight line. Now correct graph for the first order reaction. Now B is the right answer for the first order reaction. Now correct graph for the first order reaction is T of is independent of the initial concentration. ಅದಕ್ಕೋಸ್ಕರನೇ straight line ಬರುತ್ತೆ. ಇಲ್ಲಿ ನೋಡಿ they have given straight line parallel to the x axis ಬರುತ್ತೆ. ಯಾಕಂದ್ರೆ T of is not depending upon the initial concentration. Okay. No, option C and option D is also wrong. Next question. No. Next question ಏನು ಕೊಟ್ಟಿದ್ರು? For the reaction A plus B gives rise to product, it is found that order of A is 2 and the order of B is 3. Now, in the rate expression, when the concentration of the both A and B are doubled, the rate will increase by the factor. ಮುಂಚೆ ಏನು ಮಾಡೋಣ? First we have to write the rate law. Rate law for this one. Rate law is equal to K into concentration of A into concentration of B. Now here it is found that order of A is 2. Now with respect to the A, order is 2. Now with respect to the B, order is 3. Okay. Idu first rate law. Next when the concentration of the both A and B are doubled, then the rate law will be increased by a factor. Next rate law ನೋಡಿ. Next ಇದು rate law 1. Next rate law 2 ತಗೊಳ್ಳಿ. ಇಲ್ಲಿಗೆ ಸ್ಮಾಲ್ r1 ತಗೊಳ್ಳಿ, ಇಲ್ಲಿಂದ r2 ತಗೊಳ್ಳಿ. ಇಲ್ಲಿಗೆ k into, now what is saying, when the concentration of the both A and B are doubled, concentration of A and B double, if it is double, what is the rate will increase by the factor 2A into concentration of 2, now 2B to concentration of the B. Now 2 raised to the power will be 4, now 2 to the power will be how much? 8. Then 4 into 8, 4 into 8, how much? It will be 32 into K. Can I write like this? Concentration of A raised to the power 2, now concentration of the B raised to the power 3. ಇಲ್ಲಿ ನೋಡಿ, now ಇದು it is same like rate law for the one, right? Now can I write rate law 2 is equal to 32 into rate law of the one, means rate law has been increased how many times? 32 times for the rate law, means rate will increase by the factor of 32. Okay, the rate will be increased by the factor of 32. ಇಲ್ಲಿ ನೋಡಿ, first ಮುಂಚೆ ಏನು, first we have to write rate law. now ಇಲ್ಲಿ rate law ಬರೆದಿ ಆದ್ಮೇಲೆ ಏನು ಮಾಡೋಣ, rate law 2, the second expression they have given. Now both the concentration increased by the 2, then 2 to the power it is 32 and 2 raised to the power 3 is equal to 8. Now 4 into 8 is equal to 32, and this will be the same like the rate law 1. Okay, next question. Now next question ಏನಂದ್ರೆ, now the unit of rate constant of the elementary reaction depend upon. Elementary reaction ಅಂದ್ರೆ ಏನು, it will complete in the single step. ಸಿಂಗಲ್ ಸ್ಟೆಪ್ ಅಲ್ಲಿ ರಿಯಾಕ್ಷನ್ ಕಂಪ್ಲೀಟ್ ಆಗುತ್ತೆ. ಹೀಗೆ ನೋಡಿ, ಎಲಿಮೆಂಟರಿ ರಿಯಾಕ್ಷನ್ಗೆ ನಾವು 2A gives rise to product, 2A gives rise to product. Rate law is equal to K into concentration of A raised to the power its stoichiometric coefficient. ಅಂದ್ರೆ ಇಲ್ಲಿ ನಾವು ಯೂನಿಟ್ ಆಫ್ ರೇಟ್ ಕಾನ್ಸ್ಟಂಟ್ is depend on the order. Now order for the elementary reaction is equal to molecularity. ಅಂದ್ರೆ ಏನಂದ್ರೆ, when the reaction is happening, that at the slow step how many reactants are reacting, that is known as the molecularity of the reaction. Now ಇಲ್ಲಿ order is equal to molecularity. No, means the unit of the rate constant will be depend upon the molecularity of the reaction. Okay, next. For a hypothetical reaction means it is some imaginary reaction. At 2A gives rise to 3C. The reaction rate R in terms of the rate of change of the concentration is given by. First ಏನ್ ಮಾಡೋಣ, ಈ ಕ್ವಶನ್ ಸಾಲ್ವ್ ಮಾಡೋಕೆ ಮುಂಚೆ ಫಸ್ಟ್ ವಿ ಹ್ಯಾವ್ ಟು ರೈಟ್ ರೇಟ್ ಆಫ್ ರಿಯಾಕ್ಷನ್ ಫಾರ್ ದಿಸ್ ಒನ್. concentration of change in concentration of A by dt is equal to plus 1/3 change in concentration of C by dt. Now rate of reaction rate R is equal to, now this is the reaction rate R. Reaction rate R is equal to minus of change in concentration of A by dt is equal to plus 1/3 change in concentration of C by T. Now ಇಲ್ಲಿ ನೋಡಿ, match the options with this expression. First one, R is equal to minus dA change in concentration of A by dt. Now ಇಲ್ಲಿ, but they have not mentioned its stoichiometric coefficient, so this option is wrong. Next ಇಲ್ಲಿ ನೋಡಿ, now here R is equal to 1 by 3 change in concentration of A by T. Option number C you see. But here change in concentration, its stoichiometric coefficient is 1 by 2. So this option is also wrong. Now you know next is equal to change in concentration of A by T. This option is also wrong. Now for the option number 2 you know now R is equal to minus of change in concentration of A by T. Here also in the rate expression we have expressed in this R is equal to minus of change in concentration of A by T. Now this is the correct answer. Okay. Next question. Which order of the reaction obey the expression T of is inversely proportional to the initial concentration? To solve this question, I will give you one general expression. T of is inversely proportional to 1 by initial concentration raised to the power n minus 1. Ili n andre enandre n is the order of the reaction. Now which order will obey the expression T of is inversely proportional to the initial concentration? Ili first if you take the zero order, now zero tagandidu andre 0 minus 1. Now this will be A by initial concentration minus 1. Now inverse if you take to the numerator, then it will become means T of for the zero order reaction. For the zero order reaction, T of is directly proportional to the inversely proportional, but he has given T of is inversely proportional to the initial concentration. Here the T of is directly proportional to the initial concentration. So zero order reaction, it is not the answer. If you take the here, if you take the first order, T of is equal to 1 by initial concentration 0, 1 minus 1. Now something raised to the power 0, something raised to the power 0 is equal to 1, means here it will get the 1. It is T of for the first order reaction, it is not depending upon the initial concentration only. Now next second order, if you take T of is equal to 1 by initial concentration, no, n 2 minus 1. Now then it will become 1 by initial concentration. Means for the second order reaction, T of is inversely proportional to the initial concentration. Now which is the answer? P. Second order is a correct. Okay. Next question. If the volume of the closed vessel in which of the following simple reaction carried out is reduced to 1/3 of original volume, the rate of reaction becomes first rate labori. Rate is equal to rate constant into concentration of NO to the power 2 into change in concentration of O2. Now concentration, now what is the meaning of the concentration? Concentration is equal to number of moles by volume, right? Number of moles by the volume. Now right here rate is equal to K into N NO to the power 2 into NO2 by V. Now how much volume? Now carried out, reduced 1/3 of the original volume of reduced, right? 1/3 of the original volume reduce alla. Now andre here K NO2 by 1/3 of the original volume has been reduced. Illinda O2 by 1 by 1/3 of the original volume has been reduced. Now illige K now 3 into NO is to the T. Now 3 NO2. Now 3 raised to the power 2, how much it will become? 9 into here 3. Now 9 into 3 is equal to 27 times. Now rate of the reaction becomes 27 times. 27 by the rate of the reaction will be happen. Clear? Now next question. Next question. For the reaction N2O5 gives rise to 2 NO2 plus half O2, that he has given K1. Now, for this one they have given K2, for this one they have given K3. So, let's see. For this one, how to write the rate of the reaction? Minus D concentration of N2O5 by dt is equal to K1 concentration of N2O5. Okay. Next, for this one, next one what they have given? Next one what they have given? No. Plus its stoichiometric coefficient is 1 by 2. Now D change in concentration of NO2 by dt is equal to K2. How they have given? Concentration of N2 and O5. Now, for this one, half O2 they have given. Half O2 eng barbodu. Now plus change in concentration of O2 by dt by its stoichiometric coefficient, right? Now its stoichiometric coefficient it is half. Now half it will be like this. You can write like D change in concentration of O2 by dt is equal to K3 change in concentration of N2O5. Now match the K1, K2 and the K3. K1, K2 and the K3. No. K1, no, N2O5. Ili half K2 N2O5. Now ilinda 2 K3 N2O5. Now next, iga N2O5 is common. Now the leftover will be the K1 is equal to half K2 is equal to 2 K3. Now if you multiply with the 2, then it will become 2 K1 is equal to K2 is equal to 4 K3. Now match the options. So option number 1 is correct. Option number 1 is correct. Okay. Next question. Next question. In certain reaction shown below, the rate of formation of C. Rate of formation of C andre this is the rate of formation. Now is 9.6 into 10 to the power minus 2 mole per liter. What will be the rate of reaction? What will be the rate of reaction is asking. Rate of formation, how we can write? Plus rate of the reaction. Rate of the reaction is equal to, for this one how we can write? Plus 1 by 3 change in concentration of C by T, right? Now here the rate of formation of the C, how much they have given? 9.6 into 10 to the power minus 2, means 9.6 into 10 to the power minus 2 by its stoichiometric coefficient. How much it will become? 3.2 into 10 to the power minus 2. 3.2 into 10 to the power minus 2 is the correct answer. Okay. Next question. In the data given below, he has given some data. Now he is asking the reaction may be. Which order reaction is asking? First for this one, write the rate law. Now how to write the rate law for this one? R is equal to K1 concentration of A by concentration of B. Rate how much they have given for this one? Rate how much they have given? 3.0 into 10 to the power minus 3 is equal to K1. Now concentration of A how much they have given? 0.02, and concentration of B how much they have given? 1 by 2. Now write the same rate law for this expression also. Now how much the rate they have given? 6.0 into 10 to the power minus 3 is equal to K2. Now concentration of A, now raised to the power m and raised to the power n, let's take. Now concentration of A, second how much they have given? 0.04. Now B how much they have given? 2.4. Okay, now divide equation 1 and let's take this is 1, this is 2. Now divide 2 by 1. Divide 2 by 1. Now if you divide 2 by 1, how much it will become? 6 into 10 to the power minus 3 is equal to K2 by K1. This is a constant only. 0.04 into 2.4 by 3 into 10 to the power minus 3. Now concentration of 0.02 into concentration of 1 by 2. Now you know 0.02 and 0.04 it will become 2. Now 1.2 and 2.4 it will become 2. Now 2 to the power m and 2 to the power n. Now here 3 will get cancelled. Now what will get? Now what will get? I am writing here for this one. Now 2 is equal to 2 raised to the m plus n. Now m raised to the power. Now order of the reaction is asking. Now reaction may be now m plus n. Now order is rate of the reaction order is 1. So the reaction is first order. Reaction is a first order. Okay. Next today. If the rate of reaction increases 2 times when that every 10 degree raise in temperature. Now what is saying? Rate is rate of reaction. Rate of reaction is doubled when 10 degree raise in temperature. Means here rate constant is directly proportional to the temperature. Rate constant is directly proportional to the temperature. Now rate law, how we can write? Concentration raised to the power n. Means rate of reaction is directly proportional to the concentration. Concentration is directly proportional to the temperature. If the temperature increases, rate constant increases. If the rate constant increases, rate of the reaction increases. Means what they have given, rate of the reaction is doubled when the 10 degree raise in temperature. Every 10 degree raise in temperature, rate of the reaction is doubling. Now, then if we raise the temperature by 40 degree, the new rate of the reaction is saying. Now, from 10 degree to, you have raised it to the 20 degree. Now, 20 to 30. Now, 30 degree to 40 degree, you have raised it. Now, 10 degree to 20 degree. Now rate of the reaction has been doubled. Now 20 degree to 30 degree. Now again rate of the reaction is doubled. Now 30 degree to 40 degree. Again the rate of the reaction has been doubled. Now ಇಲ್ಲಿ ನೋಡಿ. Now from 10 degree to 20 degree, you have raised 10 degree. Every 10 degree, when you are raising the temperature, temperature to the 10 degree, now what happened? Reaction, rate of the reaction is also doubling, right? Now 10 degree to 20 degree, 1 double. 20 degree to 30 degree, again 10 we have increased, now double. Now 2 to the power 3, 2 to the power 3. Now the new rate of the reaction will be 2 to the power 3 will be equal to 8 times. So the answer will be B. Answer will be the B. Okay. Next, A plus B gives rise to C. Now delta H is positive 60 kilojoule per mole. Now activation energy of the forward reaction, actually this is forward reaction, activation energy of the forward reaction is 150 kilojoule. Then the activation energy of the backward reaction is how much? Now how to identify the activation energy? Illi nodi, one reaction I am taking, this is reaction. Now this is the progress of the reaction progress, or reaction let's take. Now here the energy of the reactant. Now this is the energy of the product. Now here this is the threshold energy. Now here this is the activation energy. Now this is the activation energy. Now this is the activation energy of the forward reaction. No. Here to here. Now this is the activation energy for the backward reaction. Activation energy for the forward reaction. Here to here the activation energy for the backward reaction. Illi nodi. Now E difference ಏನಂತಾರೆ ಡೆಲ್ಟಾ ಎಚ್. ಈ ಡಿಫರೆನ್ಸ್ ಇಸ್ ದ ರಿಯಾಕ್ಟೆಂಟ್ ಮತ್ತೆ ಪ್ರಾಡಕ್ಟ್ ಡಿಫರೆನ್ಸ್, ಅದನ್ನೇನಂತಾರೆ ಡೆಲ್ಟಾ ಎಚ್. ಇಲ್ಲಿ ಡೆಲ್ಟಾ ಎಚ್ ಇಸ್ ಈಕ್ವಲ್ ಟು activation energy of forward reaction minus activation energy of the backward reaction. Activation energy of the activation energy of the forward reaction ಮತ್ತೆ activation energy of the backward reaction. ಇಲ್ಲಿ activation energy of backward reaction is high. Activation energy of the backward reaction high ಇದೆ ಅಂದ್ರೆ delta H will be negative. Delta H will be negative. Activation energy of the forward reaction is more than the activation energy of the backward reaction ಇದೆ ಅಂದ್ರೆ delta H will be positive. Delta H will be positive. Okay, ಇಲ್ಲಿ ನೋಡಿ delta H is positive ಅಂದ್ರೆ delta H is positive ಅಂದ್ರೆ activation energy of the forward reaction is high. Now delta H is equal to activation energy of forward reaction minus activation energy of the backward reaction. Delta H ಕೊಟ್ಟಿದ್ರು, how much they have given? 60 plus activation energy of the forward reaction also they have given 150 minus they are asking activation energy of the backward reaction. Now, take activation energy of the backward reaction is equal to, bring the 60 to the right hand side, 150 minus 60, how much it will become? 90. Answer is C. Okay, ನೋಡೋಣ. ನೆಕ್ಸ್ಟ್ ಕ್ವಶನ್ ಯಾವ್ದಂದ್ರೆ the first order reaction is complete 50% in 50 minutes, then the time required for the initial concentration to be reduced to the 12.5%. For this one, to solve this one we have to use the calculator also. First we'll see. Now T of the first order reaction, T of is equal to 0.693 by K, right? Now T of how much they have given in the question? 50 is equal to 0.693 by K. Now K is equal to 0.693 by 50. Now how much it will get? How much will get? 0.693 by 50, it will give 0.01386. Okay, but he's saying then the time required for the initial concentration to be reduced to the 12.5%. Now first order reaction formula we know, right? K is equal to 2.303 by T log initial concentration by final concentration at the time T. Now here T 12.5% we have reduced, 2.303. Now I brought the K to the right hand side. Now K how much we got? 0.01386 log initial concentration is 100. Now final concentration we have reduced to the 12.5. Now see here log 12. Now log 100 by 12.5 is equal to almost we got 0.9. This value, this entire value we got 0.903. Now we'll see this value, 2.303 by 0.01386. how much we got? 166. This we got 166.16. now if you do into 0.903. So exactly we got the 150.04 minutes. Is the answer is the option number here. If this type of the complicated any calculation it is there, log value or anything other values, they will mention it in the questions. Okay. Next question we'll see. Next question. The rate constant of the reaction depend upon. Here the rate constant of the reaction will depend upon only temperature. Rate constant of the reaction will depend upon the which one? Only on the temperature. It is not depend upon the concentration and the volume of the container. Okay. Next question is, for the equilibrium, A gas gives rise to equilibrium with the B gas, delta H is 40 degree. Now, if the ratio of the activation energy of the forward and the reverse reaction is 2/3, then, now we know, right? We got the delta H is equal to activation energy of forward minus activation energy of backward. This is B. But ಇಲ್ಲಿ ಏನು ಕೊಟ್ಟಿದ್ರು, rate of forward reaction and the reverse ಅಂದ್ರೆ backward reaction is 2/3. Now, ratio of activation energy of forward by activation energy of backward is equal to 2/3. Now, ಇಲ್ಲಿಂದ activation energy of the backward, if you take to the right hand side, activation energy of forward is equal to 2/3 activation energy of the backward. Now, ಇಲ್ಲಿಂದ ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡಿ. ಡೆಲ್ಟಾ ಎಚ್ ಎಷ್ಟು ಕೊಟ್ಟಿದ್ರು? -40 is equal to activation energy of forward reaction ಎಷ್ಟು? 2/3 activation energy of backward minus activation energy of backward. ಇಲ್ಲ, ನಾವು ಸಾಲ್ವ್ ಮಾಡಿದ್ವಿ ಅಂದ್ರೆ ಎಷ್ಟಾಗುತ್ತೆ? 2 activation energy of backward minus 3 by activation energy of backward by 3 minus activation energy of B by, now 3 if you bring to the left hand side, then it will become 120. Minus will get cancelled. Minus will get cancelled. Then it will become activation energy of the backward will be equal to 120 kilojoule per mole. Okay. Now this is for the activation energy of the backward reaction we got. Now same ide activation energy of the backward reaction no ಈ ವ್ಯಾಲ್ಯೂನು ಇಲ್ಲಿಂದ ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡಿ. ಎಷ್ಟು? ಡೆಲ್ಟಾ ಎಚ್ ಎಷ್ಟು ಕೊಟ್ಟಿದ್ರು ಅವರು? 40 minus activation energy of forward reaction we have to find out. Now how much activation energy of backward reaction? ಎಷ್ಟು? 120, right? Now activation energy of forward is equal to, now minus 120 if you brought to the right hand side, then it will become plus 120. 120 minus 40, it will become plus 180 kilojoule per mole. Now, activation energy of the backward is to 120, activation energy of forward is to 80. Activation energy of forward is 80, activation energy of the backward is 120. So option number A is correct. Okay. Next question. Now, next question, how to solve. ಈ ಕ್ವಶನ್ ಹೆಂಗ್ ಸಾಲ್ವ್ ಮಾಡ್ಬೋದು? ಈ ತರ ಕ್ವಶನ್ ಕೊಟ್ಟಿದ್ದೀರಾ ಅಂದ್ರೆ ಫಸ್ಟ್ ನೀವು ಏನು ಮಾಡಿ, ರೇಟ್ ಲಾ ಬರಿ. ಇಲ್ಲಿಗೆ ರೇಟ್ ಲಾ ಅಂದ್ರೆ ಏನು? R is equal to K concentration of A concentration of B raised to the power M and N, right? Now ಈ ತರನೇ ಇಲ್ಲಿಗೂ ರೇಟ್ ಲಾ ಬರಿಬೋದು. Write the rate law for this one. Or for this one, rate how much again? 0.04 is equal to K. Now concentration of A to how much again? 0.2 raised to the power A. Now concentration of B how much again? 0.2 raised to the power B. Now let's take this is the 1. Now same for this one also, 0.04. Now concentration how much again? 0.1 raised to the power A. Now concentration of B 0.4 raised to the power B. Now for this one also 0.08. Concentration of A 0.2 raised to the power A. Now 0.4 raised to the power B. Now this is 2. Now this is 3. Now here you have to find out order with respect to A2 and the B2. Now means you have to find out the A and the B. How to solve this question? Now ಇಲ್ಲಿ ನೋಡಿ. Now divide the first you divide 3 by 1. Divide 3 by 1. 3 by 1 divide ಮಾಡಿದೀವಿ ಅಂದ್ರೆ 0.08 by 0.04 is equal to, ನಾವು ಇಲ್ಲಿಂದ ನೋಡಿ 0.2 same. Now k by 0.2 by k 0.2 of A. This is same, we can cancel out. Now here 0.4 of B by 0.2 the concentration of B. ಇಲ್ಲಿ ನೋಡಿ 0.4 0.2 ಎಷ್ಟಾಗುತ್ತೆ 2 ಅಲ್ಲ. ನಾವು 0.2 0.4 ಎಷ್ಟಾಗುತ್ತೆ 2 ಅಲ್ಲ. ನಾವು here 2 into 2 to the raised to the power B. Now here the power is 1. Now order with respect to B is 1. Now for the A also we can do the same. Now here we have to do divide 3 by 2. If you do the 3 by 2, how much it will become? 0.08 by 0.04 is equal to, now k 0.2 raised to the power A by k 0.1 raised to the power A. Now here 0.4 raised to the power B, 0.4 raised to the power B. Now 0.4 will be get cancelled. Now here it will become 2. Here also it will become 2. Now 2 to the power 1 is equal to 2 to the power A. Now A is equal to 1. Now order with respect to A is 1. Now order with respect to B is also 1. Now the option number A is correct. Option number A is correct. Okay. Next. Now dx by dt is equal to k. Now this they have given. What is the order of the reaction? Now sum of this will give the order of the reaction. Now here k dx by dt is equal to, concentration, order of the reaction, this one is 0.5. Now sum of the, see this one. Now sum of the order of these reactions will give the total order. 0.5 plus 0.5 plus 0.5. Now it will become 1.5. Now order of the reaction will be, total order of the reaction will be 1.5. Next. Now if the half-life of the first order reaction is 50 seconds, what will be the value of the rate constant is asking. Now we know, right, we go to T of is equal to 0.693 by K. Now half-life of the first order reaction is 50 seconds. Now T of ಎಷ್ಟು ಕೊಟ್ಟಿದ್ರು ಅವರು 50. 0.693 by K. Now if you bring the K to the left hand side, now 6.093 by 50 by 50. Now ಎಷ್ಟಾಗುತ್ತೆ something 0.013 something it will get. Now is the option it is there, or it will get 8. Now if you bring the point to here, then it will become 0.138 into 10 to the power minus 1. Still if you bring here 1.38 into 10 to the power minus 2 second inverse. Now option number 1 is correct. Next. Which of the following can change the rate constant of the reaction? Rate constant of the reaction when the temperature is changed and the catalyst is added, then only the rate constant will be changed. Means option both A and C. Okay. Next question. Identify the correct one from the graph. Now here the energy versus the reaction progress they have given. Now here there is a intermediate, it is there, means it is a two-step reaction. By the graph we get to know this is a two-step reaction. Now, by this, step 1 is the slower than the step 2. Now, here, this is the up to here the slow process, then it will become the faster. Then it will become the faster. Now, here, this is option A is correct for this one. Next question. Next question, Ganodi. Now, the correct expression for the Arrhenius equation is where the K is rate constant. Now, Arrhenius equation andre enu? No. Arrhenius equation andre enu? No. K is equal to A into E raised to activation energy by RT. Idiyalla? Now, for this one, we have to see the correct one. Now, by applying the ln K to this one, then it will become ln A plus ln E raised to EA by RT. EA by RT. Now, we know, right? Ln E power x is equal to x. E power x is equal to x. Means ln K is equal to ln A minus EA by RT. EA by RT. Now, if you bring this ln A to the left hand side, then it will become ln K by ln A is equal to minus EA by RT. Minus EA by RT. Now, this we can write it as ln K by A is equal to minus EA by RT. Now, if you bring the negative to the left hand side, then we can write like this. Now, ln A by K is equal to EA by RT. EA by RT. Now, we'll see whether this it is there in our option or not. Now, first one, K is equal to A into EA by RT. Now, but here they have given E delta H they have given. Instead of activation energy, delta H they have given. This is the wrong. Now, ln K is equal to EA plus RT plus ln A. Now, ln K plus ln A, here they have given plus. It should be the negative, right? Now, that is also wrong. ln K plus EA plus RT, that is also wrong. It should be a negative. Then option D is correct. ln A by K is equal to EA by RT. Okay. Next question. Next question. The temperature coefficient of a certain reaction is found to be 3. If the temperature changes from 25 degree to 55 degree, the new rate of the reaction will be. Now, munche nanu helidinalla. Now, temperature coefficient of the 10 degree by the raise of 10 degree, rate of reaction is increasing by the 2. Illi ಏನು ಕೊಟ್ಟಿದ್ರೆ rate of reaction is increasing by the 3. Rate of reaction is increasing by the 3. Now, the new rate of the reaction from the 25 degree to the 55 degree, the new rate of the reaction will be. Now, ಇಲ್ಲಿಂದ ನೋಡಿ 25 degree to 35 degree, from 35 to 45 degree, from 45 to 55 degree. Now, from year to year 3 to the power 1. Now, year to year 3 to the power 2. Now, year to year 3 to the power 3. From 25 degree raised to the 55 degree to raise the temperature to the 55 degree. Now, how much times it is increasing rate of the reaction? 3 to the power 3. Now, 3 to the power will be equal to 27 times. 27 times the new rate of the reaction will be. Okay. Next. The rate constant of the reaction, something the rate constant they have given. By seeing this unit, we can identify the rate of the reaction. By seeing this unit, how we can find out the rate of the reaction? Now, general expression for this one will be mole 1 minus n. Now, liter n minus 1, second inverse. Now, by seeing this unit, we can identify the order. We can identify the order. Now, how to identify? Now, let us assume if it is a first order. Let us assume it is a 0 order. Let us assume 0 order. N is the order of the reaction, right? N is order of reaction. Now here, if it is a zero order, then the unit will be mole raised to the power 1, because here 0 minus 1 and the second inverse. Clear? Now here, is this matching with this unit? No, right? Now if it is a first order, then it will become mole 1 minus 1, liter 1 minus 1 and the second inverse. Now, is it matching with this one? No, right? Now this will become 0, this will become 0. The unit for the first order reaction will be second inverse. Second, now if it is a second order reaction, mole 1 minus 2, now liter 2 minus 1 and the second inverse. And the second inverse. Now this will be the mole inverse, liter and the second inverse. Now is it matching with this one? No, right? Now if it is a third order reaction, then it will become mole 1 minus 3, liter 3 minus 1 and the second inverse. Then it will become mole raised to minus 2, liter square and the second inverse. Now is this unit is matching with this one? Yes, right? Now the order of the reaction will be 3. Order of the reaction will be 3. Now next one. Now which of the following given graph represents the first order reaction? Now first order reaction what is the formula for the first order reaction? K is equal to 2.303 by T log concentration of initial concentration at time t is equal to 0 and the final concentration at the time t is equal to t. Now this is the formula, right? Now here we'll see, take the KT to the left hand side. Now bring the 2.303 is equal to log A raised to by final concentration T. Now here this is in the form of Y. Now this is the X. Now this is the slope M. Now first graph you see, now T of is inversely, or it is independent of the initial concentration, right? Now when it is independent of the initial concentration, now the graph should come the straight line, but they have given parallel to the x-axis it should come, but they have given the straight line, so this option is wrong. Now here also T of is independent of the initial concentration, it should come the parallel to the x-axis. They have given the downwards arrow. Now this is also wrong. Now here product versus time, this is also wrong. Now here you see, now here they have given log initial concentration by final concentration at time t is equal to t. Now time versus time. Now this is the y, now this is the x, and the slope is k by 2.303. Now option number D is correct. Option number D is correct for this. So okay, next question. Next question, a catalyst increase the rate of reaction by. He is asking, a catalyst increase the rate of reaction by, identify the correct statement. Now decreasing the value of the Arrhenius constant. Now that is the wrong. Now increase the enthalpy of the reaction. That is also wrong. Now decrease the activation energy. Now this is the correct. Now how it will decrease the activation energy? What it will do? Now graph energy versus reaction progress if you take. Now let us assume for this reaction to be converted into product, this reactant to be converted into product. Now here if it is a threshold energy, now this reaction to convert into product, now it should cross its threshold energy. Now this is the activation energy. Now this is the activation energy of the reactant. Now this is the activation energy of the product. This is the activation energy of the product. Now if you add a catalyst, what it will happen? Now threshold energy will be decreased. When the threshold energy will be decreased, now what happened? Now activation energy also will become less, right? activation energy also will become less, right? Now decrease in the activation energy by the adding the catalyst, decrease in the activation of the energy. Okay, next the unit of rate constant of the first order reaction. Just now we have seen, right? ಈಗ ನೋಡಿದ್ದೀವಲ್ಲ, now unit of the first order reaction ಏನು, mole 1 minus n liter n minus 1 second inverse. Now for the first order reaction, right? Now n is the order of the reaction, mole 1 minus 1 liter 1 minus 1 and the second inverse. Now this will become mole raised to 0, liter raised to 0 and the second inverse. Now unit of the first order reaction is second inverse. Okay, next. Already we have seen this question, this type of the model question, but once again we are going to see. But here the delta H, they have given the minus 60. Here the delta H is negative andre exo. We know, right? Delta H is equal to activation energy of forward minus activation energy of the backward alla. Now delta H ಎಷ್ಟು ಕೊಟ್ಟಿದ್ರು, 60 minus activation of the forward, how much they have given, 130 minus activation energy of backward we have to calculate. Now if you bring minus activation energy of the to the which side, if you bring it to the left hand side, then it will become activation energy of backward minus 60 is equal to 130. If you take this minus 60 to the right hand side, then it will become activation energy of the backward will be equal to 190 kilojoule per kilojoules. Now 190 per kilojoule. Now what is the answer? Option number B is correct. Option number B is correct. Now by this we have completed our Super 30 questions of KCET of chemical kinetics. We have completed. I hope it is clear for you. Now we'll see in the next class. Okay, bye.